Hello. So we just finished talking about how our sequence vocabulary works, and we're going to go ahead and actually write a rule or an equation to get from the position number, our input, into the output, the value. So those are the vocabulary words we just talked about. So we are going to go ahead and plug this information into our table. So remember, we said that these are our values. 8, 11, 14, and 17 are our values that we're getting out, so they go in the output section. And this should look familiar from last year. Our input then is what? Our input is the term or the ordered list. It is the numbers that correspond with those. So 8, remember, was the first term. 11 was the second, third, fourth, fifth, and so on. So when we do sequences and they don't give us the inputs, we always plug in 1, 2, 3, 4, 5, because it is an order. That is the order that these numbers are occurring in. First, second, third, fourth, and then fifth. So go ahead and fill that in your process column and your table. Awesome. So now we need to go ahead and talk about the sequence rule or equation. Remember, we said it was following a set pattern. So first we need to figure out what is the set pattern for our output. How are these numbers changing? We should have already done that since we got 20 plugged in for the next term. You said that it was increasing by 3 each time. So 8 plus 3 will get you 11. Hold on. Our rule, our pattern is saying that 8 plus 3 will get us 11, 11 plus 3 will get us 14, 14 plus 3 will get us 17, so our output is changing by plus 3 each time. Then our input, since it's just our position numbers, this one's easy, it's always going to be plus 1, because our position numbers are increasing by 1 each time. So remember, when we write our rule then, we talk about the change in output compared to the change in input. So fill in your change in output over your change in input. That would be 3 over 1. It's positive 3 since it was going plus 3. It's positive 1 since it was going plus 1. Well, 3 over 1, 3 divided by 1 is simply 3. So our change in output over our change in input, our rate of change is 3. Now we want to come up with a process or a rule that will get us these numbers even if I wanted to plug in the 100th term or 200th term. I don't possibly want to keep this table going all the way up to the numbers 100 or 200. It would take forever. So a faster way to say plus 3, plus 3, plus 3, plus 3 over and over and over again is to do what? Awesome. Multiply by 3. So go ahead and fill in this process column with the position number times 3. And there we go. So make sure you had that down. Pause the video and write it down if you don't. So we have 3 times 1, 3 times 2, 3 times 3, so on and so forth. Now tell me, does 3 times 1 get me the value I want? What is 3 times 1? Yes, 3 times 1 is 3. So what do I have to do to the number 3 to make it 8? Well, 3 times 1 gets me 3, so I have to add 5 to 3 to get 8. 3 times 1 is 3, plus 5 is 8. Let's try the next one. 3 times 2 is 6. Well, we're saying plus 5 should work. 6 plus 5 is indeed 11. So now we have created our process column. The rule and equation we're going to follow is 3 times n plus 5. So fill that in for the entire table now. So pause the video if you needed to finish filling that in. So notice we plugged in 3 times the position number plus 5. That means that our rule for this table should definitely be 3n plus 5. So let's double check with that 5th term that we said earlier should be 20. 3 times 5 is 15 plus 5 is 20 indeed. So that means that we created the rule right. It works for all of the position numbers. And if I wanted to, I could plug in any position number, the 100th term, the 200th term, and get out the value that corresponds with that position number. So this is the practice problem that you are going to do to see if you understood this video, and then pick to do an easier video or harder video. Pause the video now and try it.